On page 445, number 1 is a story problem. It says there are 7 friends waiting to ride the new roller coaster. How many ways can they board the ride once it's their turn? So we have to think about, once someone's on, they're on, right? So how many people can get on first? 7. But once someone, let's say once Michaela gets on, is she a choice for the next person to get on? No. So what's the choice for the second person? How many are there? Only 6. So once Michaela and Nate get on, if they're our first and our second choices, how many people are there for the third choice? 5. How about our fourth choice? 4. And then our third choice? Noticing a pattern? Oops, I'm sorry, it's our 5th choice. Good work. That's our 5th choice. Now our 6th choice has how many people? Just 2. And then our very last person, how many are there? Just 1. I do not want to make a tree diagram for that. What fabulous principle do we know and love that's going to help us figure out how many total ways they could board there? Dale, yes, what principle is that? He's right. We are going to multiply all of these ways. What principle that we learned last week tells us that we can do that? Emma? Write this down on your paper, except Emma, because she knows it. Write down the fundamental counting principle. That is the mathematical term that we proved last week, right? We know that works. So we do not have to do a tree diagram unless it's required ever again. Okay. How am I going to do this? Emma? You're going to multiply them all. I like to start this way and go backwards, because 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24, right? 24 times 5. How would I find out? Use a calculator. When you plug all of those in, good. I think you're right. It's 5,040 arrangements. It's 5,040 arrangements, or write this label, permutations. Permutations. That's a word you need to know. What is a permutation? It's in yellow. What's a permutation? Shaylin. Good. And so because order matters, once Michaela got on, we didn't have her as a choice. Remember? The last time we had, when I did my pizza example, there were crusts and then toppings and then cheese, and all of them were different. Here, all of our choices are people. But we have a different number of people every time. Making more sense? Let's try another one. Let's try number 3. Number 3 says that there are 5 seasons of your favorite TV show on DVD or on your television. Okay, not very many of you have DVDs anymore, right? If you randomly select 2 from a shelf, what is the probability you'll select season 1 first and season 2 second? Oh crap, they're asking about probability. What do you have to do for probability? Everybody raise your hand. Ooh, I know probability. What is probability, Nate?
The amount you want equals, okay. The amount you want over the total amount of stuff.
Total amount. That's your probability. Ooh. Well, how many ways could I get season 1 first and season 2 second? How many ways can I do that? What 2 ways? If I get season 1 first and season 2 second, how else can I do that? How many ways? There's only one way. You're right. There is only one way to get season 1 first and season 2 second. So I'm going to put a 1 on the top. Do you see why? There's only one way to do that. Oh crap, how do I figure out how many total ways there are to pull those DVDs off the shelf? How many ways are there? Well, what about my first pull? How many ways are there if I pull one video off? 5. But once I have season 1 in my hand, do I put it back? No, so my second pull has how many ways?
4.
Only 4. Oh wait, what pattern are you noticing? The next one, it's going to be how many choices? 3, and then 2, and then 1. Ooh, how am I going to figure out how many total ways there are? Multiply, because why? What principle am I using? It's the...
Fundamental counting principle.
So everybody but Emma and Nate have to write down that we're using the fundamental counting principle, because I want everybody to say it. Everybody needs to know it. It's the fundamental counting principle that lets us do this. Write it down. 1 times 2 is 2. 2 times 3 is 6. 6 times... Oh, wait a minute. How many are we picking? Are we picking all of them, you guys? No, we're only picking what? 2. We're only picking 2. It'll just be 20. It'll just be 20 because we're only picking 2. So what's my probability? What's my probability? What is it? 1/20. Oh, be a careful reader, Mrs. Smith. So the probability of season 1 and then season 2 is 1 out of 20th. Do you see why we didn't go all the way down? Because how many movies did we pull? Just 2. We only pulled 2 movies. I think I'm with you, Mrs. Smith. Turn the page. Turn the page. Let's look at 5.